Okay, let's jump in. If you've ever seen a massive industrial project, I mean, a new power plant, a huge data center, you get a sense of the sheer effort it takes to build it.
Oh, absolutely.
But the real moment of truth, the biggest contractual hurdle where all the risk shifts,
Yeah.
it's not putting up the last wall.
No, not at all. It's making the thing actually work.
Exactly.
It's that critical and honestly sometimes terrifying transition.
Hmm.
You're going from a construction project to a living, breathing asset. And that's what we're diving into today. The contractual blueprint for that exact moment.
The employer requirements for commissioning and startup, CNSU.
Right. And this isn't, a friendly guideline. It's a legally binding instruction manual. Every single step is designed to wring out every possible risk before the operations team even touches a button.
So if you're in a role where you're dealing with major projects, or maybe you're just curious about how these massive investments are protected, here's our mission for this deep dive.
We want to pull back the curtain on the really structured, verified, documented steps that take a project from being just built to actually being operational.
We want you to see the specific contractual gates, the ones that separate a complete structure from a machine that actually functions and, makes money.
And before we go any further, we absolutely have to define three key terms
Yes.
because you can't mix them up. Contractually, they're totally distinct milestones with very different legal consequences.
Okay, let's do that. These are pulled straight from the requirement documents, but let's talk about what they mean in, the real world.
First up is commissioning.
Commissioning.
Functionally, commissioning is basically the process of testing all the individual bits and pieces, the individual systems.
Okay.
The source docs define it as verifying the work so. All the equipment, the plant verifying it, all meets the design specs and was installed correctly. You do that through inspections, checks, and tests.
So it's like, does this specific motor tune on? Does this pipe hold pressure? That level of detail.
Exactly. It's verification, system by system. A very granular process.
So if commissioning is checking the parts, what's next? That brings us to the big one, right? Ready for startup.
RFSU.
RFSU. This is the golden ticket. This is the contractual declaration that says the facility is ready. Ready for fuel, ready for power, ready to be used.
So it's the moment of confidence.
A highest level of contractual confidence, yes. It means all the systems are commissioned, all the startup prep is done, and crucially, the whole thing can be started up and used for its intended purpose safely. Safely. That's the key. Always. And that leads to the final phase, startup.
Right.
And startup is the period from RFSU all the way until the facility is available for full capacity operation.
So the shakedown cruise.
The operational shakedown cruise, exactly. The whole point is a safe, controlled initial operation with, ideally, a bare minimum of defects.
Okay, that makes sense.
Yeah.
So let's talk about the rigor of that first phase commissioning. We said it's verification, but the planning and paperwork behind it is immense. It's an administrative Everest. And it's where the contractor really has to prove everything. The contract is designed to mitigate the biggest risk in any big project.
Scope overlap.
Scope overlap. When you have dozens of specialized contractors, the place where things fail is at the interfaces between their systems.
So how do you solve for that contractually?
You force integration. The contractor has to submit a detailed integrated commissioning plan.
And what's really interesting there is that the plan can't just be about their work.
No, not at all. They have to actively go out, coordinate, and incorporate the commissioning plans from all the other contractors on the site.
It's mandatory integration.
It forces systems thinking. They have to define exact system definitions, break the whole facility down into manageable chunks, and then create these things called test packages.
A test package.
Think of it as a binder, a folder for every single component. It's got all the check sheets, the inspection forms, the sign-offs, everything.
And that detail creates accountability. It's not just a general check. We're talking about required site acceptance tests or SATs for big pieces of equipment.
Right, like a massive pump or some specialized turbine. The contractor can't just install it. They have to prove on site with the employer watching that it works in that specific context.
That level of planning has to be tied to safety, right? You mentioned the contractual terror earlier. This is where it gets very real.
Absolutely.
Yeah.
I mean, think about it. You're about to put power into a facility that was just cold steel a few weeks ago.
So the documents mandate a really high standard for something called energization management.
Which is just a formal way of saying they need a very careful plan for how and when systems get electricity, and it all has to follow strict HSE health, safety, and environment rules.
And this is a point you should really focus on. The contract actually requires the designation of an authorized electrical person, an AEP.
And the AEP is not just, any old electrician.
Mm.
They are the single contractually defined person who is in control of and liable for energizing that entire site.
So if something goes wrong during that process, the liability points to that one specific person.
It's hyper-specific risk transfer. And during all this work with live power and moving parts, there has to be a formal work permit system that the employer has approved.
The site stays a very controlled environment.
And beyond safety, you hit the simple logistics. The contractor doesn't just build the machine.
They have to bring the fuel.
They have to bring the fuel. They procure and supply all the commissioning spare parts and consumables, the oils, the chemicals, the first fills. They have to stock the fridge, basically.
And here's a great little clause for protecting the asset. Until that RFSU milestone is officially hit, the contractor is on the hook for all maintenance.
Right, as per the vendor's requirements. They can't hand over a facility that's been sitting idle and degrading for a month. It has to be actively maintained.
And none of this is just taken on good faith. It's all proven through a massive paper trail, or, more likely, a digital trail.
This is where you really see the power dynamic in the contract.
How so?
We talked about the integrated commissioning plan and the manuals, but the employer demands real-time transparency.
Okay.
The requirements explicitly say the contractor has to use an online commissioning software, a tracking system.
And the key is?
The employer and their team must have full online access to it.
Ah, I see why that's so crucial. If it was paper or offline, someone under pressure could, backdate a sign-off.
Exactly. Or complete the documentation after the fact. By mandating a live online system that the employer can see, you get a verifiable time-stamped record of every single check.
It prevents the records from being fudged to meet a deadline.
Precisely. It keeps documentation in lockstep with physical work.
So all of that documentation, all that verification, it's all leading up to that critical checkpoint.
RFSU, ready for startup.
Okay, so before you can actually flip the switch, the contractor has to do some very specific physical prep work, right? We're moving beyond tests now.
Right, this is about operational setup. These are the real-world things you have to do before you start. The source material lists things like the first fills.
The oils, lubricants, water.
All of that, and also the flushing, cleaning, and drying of all the process systems.
Because you can't start a factory if the pipes are still full of construction dust.
Or just standing water. And as we get to this final review, we hit the punch list.
Now, this can be confusing because there's usually a mechanical completion punch list.
A totally separate thing. The contract is very clear about this. The commissioning punch list is different.
And that distinction is vital.
It is. Think of it this way. The mechanical completion punch list asks, did you build it according to the drawings?
Okay.
The commissioning punch list asks a different question. Will this system run safely and efficiently when we turn it on? It tracks any gaps between the employer's requirements and what's actually there right before RFSU.
And safety, again, gets the final say.
Always. Any mandatory recommendations from a pre-startup safety review, a PSSR, they must be added to this punch list immediately.
So if the safety review finds a potential hazard, that hazard becomes a contractual blocker to RFSU.
Until it's fixed, yes. Which, brings up a very practical problem, doesn't it?
With schedule.
The schedule. What if the contractor just can't get every single minor thing done before the big RFSU date? The contract actually plans for this.
It anticipates the tension.
It does. The procedure for the punch list has to identify items that are proposed not to be completed as part of RFSU.
This is the famous exception list.
The very delicate, highly negotiated exception list. And if the contractor wants to put something on that list, meaning they'll finish it after RFSU...
They can't just decide to do it.
Oh, no. They have to submit a formal proposal. They need to give solid reasons and a firm binding date for when it will be completed. It turns a problem into a managed contractual risk.
It's a real high-stakes negotiation because you need the startup team to get into the critical systems, even if, some other less important area is still technically being worked on.
That's why the punch list items have to be prioritized, so the really critical systems are 100% ready to go.
So once that RFSU gate is finally passed, usually with an agreed-upon exception list, we're into the startup phase.
We're moving toward full operational readiness and ultimately the handoff.
And this is where the planning timelines get really long.
And they're designed completely for the employer's benefit. The contractor's job now is all about making sure knowledge is transferred months ahead of time.
Okay, so let's start with the blueprint for the operation, the integrated startup plan.
A huge document.
Yeah.
And it has to pull input from everybody. The original equipment manufacturers, the technology licensors, the automation contractor, and, of course, the employer's own operations team.
And that plan has to lay out the exact startup logic.
The step-by-step sequence. The conditions you need to bring the whole facility online without anything going wrong.
And the lead times for documentation here are pretty extreme.
Deliberately extreme. The contractor has to make sure all the required operation and maintenance manuals are in the employer's hands at least 6 months prior to the startup date.
6 months? That's a huge pressure point.
Yeah.
It's designed to make sure documentation isn't the last thing they do.
Exactly. That 6 months isn't an accident. The employer needs that time for their own people to actually read and understand the manuals before they have to operate the plant.
And the same logic applies to training.
Absolutely. The contractor has to provide operator training to the employer's people. Again, at least 6 months prior to startup.
And the plan for that training has to be submitted even earlier.
9 months prior.
Ah.
That 9-month lead time for the training plan tells you everything. The contract sees training and documentation not as extras, but as critical path items that have to be done way in advance.
So once the facility is running, it's not over. It goes into its final tests.
Right. You have tests on completion, which happens before the official taking over. This could include, say, a month of trial operations.
In there?
Then you have tests after completion. These are usually the big ones. The performance tests. Can the facility hit its guaranteed output, its efficiency targets? Both have to be done before the employer officially takes the keys.
Which brings us to a really interesting choice in the contract. Who is actually running the control room during this initial phase?
Yes, the source material gives 2 different models for this.
Yeah.
2 ways to handle that operational risk during the handoff.
Option A and option B.
Let's start with option A. This is often the default. It's faster for the employer. Before RFSU, the employer's team is helping the contractor's team under the contractor's rules.
Okay.
But after taking over, the moment the asset is handed over, the employer's own team takes the lead on the startup. They run the show. Controlled transfers pretty quickly.
Which means the employer takes on the operational risk earlier.
They do. Which brings us to option B. This is a very different setup, and you might want this if your team is new or the technology is really complex.
How does that work?
Under option B, after RFSU, the contractor's team stays in the lead. They are the ones starting up the plant. The employer's team is there to assist and to learn.
Ah, so operational control stays with the contractor for longer.
Much longer. It only formally transfers to the employer after a defined period of trial operations and after all the big performance tests have been successfully passed.
So if you're the employer, that choice between A and B is a major strategic decision about risk.
It is. Option B will probably cost more and take longer, but it keeps the people who built and know the asset best, the contractor, holding the liability until that facility is fully proven.
So we've really mapped out this whole journey from, checking a single bolt all the way to the full operational handoff.
It's a process that's really built on 3 huge interlocking pieces.
First, you have the incredibly detailed verification of commissioning.
Then you have the rigid contractual gate of RFSU, which is all held together by that punch list system.
And finally, you have the very structured handoff logistics of startup, with those massive 6- and 9-month planning windows.
And that whole thing, that dense contractual structure, that's the blueprint.
It's the mechanism that ensures a multi-million-dollar asset doesn't just, turn on.
But that it operates safely, efficiently, and exactly the way it was designed. It's how huge companies contractually demand reliability and manage billions of dollars in risk.
And we'll leave you with a final thought on this. It's about that tension that exists in every single one of these projects. The contract states very clearly, all punch list items shall be completed prior to issuing a notice of RFSU. That's the perfect standard.
The ideal world.
But then, in the very next breath, the contract defines this whole rigorous process for proposing an exception list for leaving things incomplete.
So that raises a question, doesn't it? Given that the employer agrees, contractually, to accept an asset that isn't 100% finished at that RFSU gate, how much of the long-term operational risk is actually being handed right back to them through that one very carefully negotiated list?
Something to think about until our next deep dive.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.